Hello Year 13s, I'm not in class today, so I'm going to make you a little video to help with today's lesson. So today we're going to look at a couple of cases with our velocity vectors. We're going to have things that have trigonometric functions in, and another situation where we have exponential functions. I've written you a little question because I think some of the examples from the booklet are a little bit abstract, and I think possibly they're really good if you're aiming for a 6 or a 7 in maths, but I think they probably go a bit further than we need to if we're not aiming quite that high. So I think this is probably a nicer place to start. So we can see that we've got a displacement vector here. You'll notice that there is a cos and a sine function in our vector. So first of all, we're going to find the distance of the object from the origin. You'll know by now that to find the distance, we do the magnitude. So you might want to stop the video and have a go at that. So I'm going to use Pythagoras' theorem basically, and we're going to look at a little trick that we can do. So it is going to be 2 cos t all squared plus 2 sine t all squared. Maybe you've had a think about what this motion will look like, having a cos function for our x displacement and a y function for our y displacement. Right, I'm going to apply these squared, so we'd get 4 cos squared t and 4 sine squared t. Now, both of these have 4 as a common factor, so I'm going to start by taking that out. And what I'm left with in the brackets is this expression cos squared t plus sine squared t. Now, in your formula guide, and it's something that we'll review as, I think, probably our final unit when we're starting our review, we have our trigonometric identities. So this is the one that we're going to be using today, that cos squared theta plus sine squared theta equals 1. So let's see what happens when we do that. That means this whole bracket here is equal to 1. So what are we left with? We're just left with the square root of 4, which is 2. So that means the distance of the particle from the origin is 2. It's always 2. It doesn't vary. So let's have a think now about how this object is moving. It's always 2 from the origin. Let's think about where it's going to start off. I'm going to draw some axes now. Right, so when t is 0, if I substituted t as 0 in, I would get the vector 2, 0. So I'm going to say 2, 0 is over here. As t increases, the x component is going to get smaller, and the y component is going to get bigger, until we get to a point where, let's go to time when t is pi by 2. Once we get there, the x component will be 0, and the y component will be 2. Okay, let's put 2 here, 2 here, and x, and there's our origin. If we keep on increasing time, cos will become -1, and sine will become 0. So we'll get to this point here. And hopefully you're seeing that this object is going to be going around in circles. And that's why it can have this constant distance of 2. So it's always going to be 2 from the origin. Okay, so, I guess that means we've also done part B, describe the motion of the particle. So it is moving in a circle with radius 2 meters centered at the origin, and it's moving anti-clockwise. Okay, so when we're dealing with displacement vectors with cos t and sine t, if it's the other way around, sine t and cos t, we're always going to get this circular shape. Maybe you might want to have a think, what happens if these numbers were not equal to each other? How would that change it? Okay, part C, find the velocity vector of the particle. Okay, well, we should be confident with that. Velocity vectors we get by differentiating. So you can pause the video, have a go at that. So I want to differentiate 2 cos t, that would be negative 2 sine t. And I want to differentiate 2 sine t, that will become 2 cos t. Okay, so there is my velocity vector, and I can find the speed of the particle at time pi seconds. Okay, so just like finding distance, when we find speed, we're going to use that magnitude. And I would like time to be pi. So maybe I'll try and do both these things at the same time. I'm going to apply Pythagoras theorem, and I'm going to substitute in time equals pi, squared, plus 2 cos pi squared, all square rooted. Okay, you can grab your calculators. I don't have mine, so hopefully I'm going to get this right. I think that is 0, and I think this is negative 2 squared. Okay, so this simplifies to a velocity of 2 meters per second. Oh, I've just realised I should really have put in some units for my first answer. Okay, so the speed of the particle at time pi seconds is 2 meters per second. What I suggest you do now is take a look at the second example for today. I'll make a little video on that one as well, if you want to take a look at it. Have a think. It's got an exponential function involved as well, so you can think about how that's going to affect this circular motion. If you are aiming for a 6 or a 7 in maths, you should probably try and work through the first example as well. It's quite long, it goes over a couple of pages. I have filled out all the notes on OneNote, so if there's places where you want to get some hints, you can take a look at OneNote. Try and think through the problem. The point of it is really to try and develop a slightly deeper understanding of what's going on with this circular motion. So it will start off quite similar to this, but it really it's trying to make you think a lot more deeply about it.